In this video, we're going to look at sum and difference formulas for sine, cosine, and tangent. So the point of these formulas is to be able to help us find an exact value for something that's not on the unit circle, but we could use some information from the unit circle. For instance, what if we had sine of pi over 12 and we wanted the exact value for that? Pi over 12 isn't on the unit circle, but we could use some things that are on the unit circle to help us figure that out. So for instance, if I wanted to get a pi over 12, I could take 4 pi over 12 and I could subtract 3 pi over 12. Which is pi over 3 minus pi over 4. And pi over 3 is on the unit circle, and pi over 4 is on the unit circle. So then how do we go about doing this? There's a set of formulas that we can use. If you don't have a sheet handy that has all of these on it, you may want to pause the video, write these down so you have them handy for the rest of the video sequence for this section, and then come back to the video and look at it. Now, since this is a sine problem, we're going to use this formula here. So sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. In this case, our alpha is going to be pi over 3 and our beta is going to be pi over 4. Now, if you have a hard time thinking in terms of radians, then turn it into degrees. So we could take pi over 12 and turn it into degrees by multiplying by 180 over pi. And when we simplify that, we're going to get 15 degrees. So we can think about that unit circle and how can we get to 15 degrees? Well, we could take 60 degrees and subtract 45 degrees, and that would give us the 15 degrees. And that's what we've done here. Now, this isn't the only way to do it, but it's one way to do it, and you just need one way. So I've broken that angle of pi over 12 down into two other angles, and now I'm going to apply the formula. Formula says that sine of alpha minus beta is equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. And then these are things we know from the unit circle. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is a half. And sine of pi over 4 is square root of 2 over 2. So we're going to get square root of 6 over 4 minus square root of 2 over 4. And there's not anything we can do to simplify that further. So there's our final answer. So let's do one more. I'm going to look at 22. So in 22, we want to find the cotangent of negative 5 pi over 12. We know cotangent is an odd function, so I can think about that negative being outside. So the cotangent of negative 5 pi over 12 is the same thing as the negative cotangent of 5 pi over 12. Now I got to think about what angles can I use. So 5 pi over 12 is equal to 2 pi over 12 plus 3 pi over 12. And that's really pi over 6 plus pi over 4. And once again, if you're not really sure where to start, write this in degrees. 5 pi over 12 multiplied by 180 over pi. And that's 75 degrees. And we can use 30 degrees plus 45 degrees. to get us to 75. Okay, so if you need to do that step in the beginning, go ahead and do that step in the beginning. All right, so now what do? We don't have a formula for cotangent, but we do have a formula for tangent, and we have a relationship between cotangent and tangent. That's the same thing as -1 over the tangent of pi over 6 plus pi over 4. And then I can go back and I can use my tangent formula up here. Tangent of alpha plus beta is equal to the numerator of tangent alpha plus tangent beta over the denominator, 1 minus tangent alpha tangent beta. So I'm going to end up with this complex fraction. I'm going to have -1 divided by, I'm going to apply that formula. We've got -1 divided by, and let's do some fancy math here. So we need to know what the tangent of pi over 6 is. So I'm going to write that over here. Tangent's the y coordinate divided by the x coordinate. So I've got the y coordinate divided by the x coordinate. Keep, change, flip. So I'm going to get 1 over square root of 3, which is square root of 3 over 3. So square root of 3 over 3 plus tangent of pi over 4 is 1 over 1 minus tangent of pi over 6, the square root of 3 over 3 times the tangent of pi over 4, which is 1. All right. So I'm going to simplify this, and then we're going to worry about that -1 divided by this fraction. So -1 divided by, so this is going to be square root of 3 plus 3 all over 3 divided by 1 minus square root of 3 over 3. -1 divided by, and I'm going to simplify the denominator of that fraction. Common denominator is going to be 3. So now I'm going to simplify this guy. So I've got -1 divided by, and when I do keep, change, flip on this, I'm going to change that division bar here to multiplication, and I'm flipping that second fraction. And you can see those are going to cancel. So I've got -1 divided by square root of 3 plus 3 over 3 minus square root of 3. And then when I divide fractions, I do keep, change, flip. And I'm just going to multiply that -1 through on the top. So I'll get -3 plus square root of 3 over square root of 3 plus 3. And then now we're going to have to rationalize square root of 3 minus minus 3, excuse me. Multiplying by the conjugate there. So we're going to FOIL. I'm going to have -3 square root of 3. Outsides will give us a +9. Insides will give us a 3. Outsides will give us a -3 square root of 3. Bottoms, fronts will be 3. Outsides and insides cancel. Last will be -9. So I have -6 square root of 3 plus 12 over -6. And then I'm going to think about splitting that numerator so I can simplify. So I'm going to get square root of 3 minus 2 here for that value. All right, so let's look at another one. And I'm going to look at number 25. This one is giving you the right-hand side of that. We're going to match it up. So we've got cosine of 70, cosine of 20, minus sine 70, sine of 20. We're going back to our formulas. So we've got cosine of 70, cosine of 20, minus sine of 70, sine of 20. So do we see how that's matching up with that first formula? Cosine 70, sine, cosine 20. I'm writing on top here. Minus sine of 70, sine of 20. All right, so we can identify alpha and beta. So this is actually asking us for the cosine of 70 plus 20, which we know is 90 degrees. So that's what we're going to write down here. That's equal to the cosine of 90 degrees. And we know the cosine of 90 degrees is the x-coordinate, which is going to be 0. Let's do more of those. And this is where you may want to pause the video, come back, and check your answer. So we've got sine of pi over 12, cosine 7 pi over 12, minus cosine of pi over 12, sine 7 pi over 12. So we're going back. So we've got sine, cosine, minus cosine, sine. You see how it's matching with this? So we're looking at sine of alpha minus beta. So sine of pi over 12 minus 7 pi over 12. So that's going to be the sine of negative 6 pi over 12, which is the sine of negative pi over 2. And if you think about that unit circle, negative pi over 2 is here. And that y coordinate is negative 1. We're going to do the same thing with this one. We have tangent of 20 plus tangent of 25. All of that's divided by the denominator, 1 minus tangent 20, tangent 25. So if we compare with those formulas, that's going to be equal to the tangent of 20 plus 25, which is the tangent of 45 degrees. And that's going to be square root of 2 over square root of 2 divided by square root of 2 over square root of 2, which is equal to 1.